In this lecture, we're going to talk about topographic maps. And let's start out by talking a little more about latitude, longitude, and then this idea of quadrangles, which is the boundaries that a lot of topographic maps in the United States are based on. So of course, latitude are the lines that run east to west around the globe. They're sometimes also called parallels because they never cross each other. And they vary from 0 at the equator to plus 90 degrees at the North Pole to minus 90 degrees at the South Pole. Lines of longitude are also called meridians. And instead of plus or minus 90 for longitude, these have to go all the way around the globe. So they go starting at 0 at the prime meridian here, which goes through Greenwich, England, to plus 180 and minus 180. And sometimes when we show both those things on a globe at the same time, we call that the graticule or the graticular network. So this is showing the lines of latitude and longitude together, and we would describe that as either the graticule, or we could say that that globe has the graticular network on it. As a quick reminder, the 0, origin of latitude and longitude is where the equator and the prime meridian cross. There's no land there, it's just in the Atlantic Ocean, just a little south of that part of Africa. So when the United States Geological Survey decided they wanted to break up the U.S. into pieces that they could map, they did it by quadrangles. And to understand these quadrangles, we first have to think about what these degrees, the 180 and the 360 degrees of latitude and longitude represent. And so we have 360 degrees of longitude, 180 degrees of latitude. This is showing a compass direction, but it's also showing all of the 360 degrees where we could point a compass. So 1 degree on this would just be between these two red lines here. And we want to divide that up because we want to map very specific parts of the globe, specifically the USGS wanted to do the United States. So they're going to divide that additionally below 1 degree. And the way that they do that is very much like a clock works. If we think of a clock, we have hours, we have minutes, and then we have seconds. And hours are divided into 60 minutes, and minutes are divided into 60 seconds. We can do the same thing with a degree. So this degree here is highly exaggerated. It would really be this angle here, but we're just stretching it out so that we can see what 1 degree would look like. And then we're dividing that 1 degree into 60 minutes. So this is what 60 minutes would look like in 1 degree if the 1 degree were exaggerated. So we're seeing 1 degree here, and it's divided into 5, 10, 15, 30, 45, 60 minutes. Each one of those minutes, so if we just took one of those minutes here, which would be less than 1/5, or would be 1/5 of the way between these two lines, we can exaggerate that once again, and we can divide that into seconds. So here we have an angle that is 1 minute of degrees of latitude or longitude, and we're dividing that once more into from minutes into seconds. So each one of these degrees would have all of these different divisions in it. We'd have 60 of these represented in this. And what we can see is because there's 60 seconds in a minute and 60 minutes in a degree, there are 3,600 or 60 times 60 seconds per degree. So when the USGS took on the responsibility before all this computer stuff about mapping the United States, they decided instead of using township, range, and section or counties or some kind of boundary like that, they were going to use these boundaries associated with latitude and longitude. But they wanted to make maps more specific than 1 degree by 1 degree. So they used minutes and seconds to divide up each degree into these things we call quadrangles. And quadrangle just means it has 4 sides. It's a rectangle with 4 sides, or it's an area with 4 sides. The top can be a little shorter than the bottom, but it's a area with 4 sides, a quadrangle. And this one represents an area that's 15 minutes by 15 minutes. And the reason I say the distances can be different is because we know that the spacing between lines of longitude is going to change as we go from the equator to the North Pole. And so this top 15 degrees would be getting more stretched out in order to make it a rectangle on a map. 15 by 50, the USGS has an entire set of maps that is 15 minutes by 15 minutes. So we're just kind of measuring, and we can see that this is a quadrangle because the lines of two different lines of latitude are always going to be separated by about the same distance, but lines of longitude is going to depend where you are. So if we did a quadrangle right at the equator, we would find that it looks like a square. But as we move up here more and more, we find a more and more elongated rectangle or quadrangle as we move further to the north. And in the United States, our maps tend to look like this. We can further divide that 15 minutes in half into 4 new quadrangles, and each one of these would have 7.5 minute change in latitude going from bottom to top, and 7.5 minute change in longitude going from the east side to the west side. So let's take a look at what these maps look like. So this is the pattern we often see associated with these maps. They have brown contours, green natural areas, blue water. But let's just talk about the boundary for now, because this is one in this is a 7.5 minute quadrangle in Wyoming, and we can see they've labeled the longitude and latitude at the top. So this line here coming across here would represent 45 degrees or 43 degrees 45 minutes north of the equator, and this line of longitude here would be 108 degrees 15 minutes west of the prime meridian. If we didn't have the west, we would need a minus sign, but we have the west, so that's fine there. In the other corner of the map, we have 43 degrees 37 minutes and 30 seconds north of the equator, and we can see the difference between this north measurement and this north measurement is 7.5 degrees, which means moving from here to here, we've moved up 7.5 degrees of latitude. Same with longitude. Over here, we're going to have a bigger value because longitude increases going to the west here, away from the prime meridian. Or if you're using negative numbers, it gets to be a smaller negative number. But since we have the west on here, let's just say it's increasing in the westerly direction. So we're going from 108 degrees 15 minutes on this side here, and over here, this line of longitude would be 108 degrees 22 minutes and 30 seconds. So once again, the difference between those two is 7.5 minutes now of longitude with between this boundary on the right side of the map and this boundary on the left side of the map.